Welcome to Fabrics and Synapse Data Engineering Explorer community, where we delve into the exciting world of data engineering. A community is a group of data enthusiasts, a place where we come together to explore, learn, share our knowledge in data engineering. In this recorded session, we had a privilege of hosting a speaker, Estera. She's a senior product manager at Microsoft and an influential speaker when it comes to big data and Spark. You may recognize her from her valuable contribution on Azure Synapse Analytics channel on YouTube. And with that being said, we invite you to join us as we revisit this valuable session.
As a Spark, like Synapse Spark product group, we are focusing on two products. One is Synapse, the second is Fabric. So I'm accountable for Spark runtime. So in both products, we have Spark runtime, slightly different, but again, the core is the Spark open source. And I'm responsible for performance features, for benchmarking, and also for creating the next runtime version that will serve both data engineering, who love Spark, dbt, and cool stuff, and also a data scientist who use mostly just clear Python. Let's start with the very known, I believe that very known slide that is a little overwhelming. So this visualization has been made by the company named First Mark Venture Capital. This visualization shows something like very interesting. Each symbols you can see on the screen represents the product or the tool you can use for doing the ML, AI, data engineering. Tons of different tools, and the main challenge is how to plug in together. So many options, so many puzzles, some are working together, some not. So our customers, and again, was previously working for like on the customer side. So we also saw so many technologies which we have to use for data engineering work, meaning we have to learn. There is also always the barrier to spend the time on discovering every tool. So learning each the piece, understanding how it works, connecting that together, takes a lot of time. So we know that it's difficult for us, for customers, for everyone. We want to have a smooth experience when, as a data engineer, because we'll focus today on that persona, we want to have access to our data, immediately access to the data once it's landing on specific storage, and then start to process it. At the same time, the famous quote from some chief data officer is that, please make things simpler. I want to focus on being a chief data officer, not a chief integration officer. So our job, both like one product group, both products, is to make the puzzles easier, simpler, connected with each other. Now, starting with just 3 slides before hands-on about the Fabric for those who are believe that not hearing the first time, but maybe not familiar with the tool. So you can think about Microsoft Fabric as an office, but targeting just your data. So as you can use Word in Office, PowerPoint in Office, Excel in Office, there are multiple engines, scenarios that are defined in Fabric. So basically you can see 7 tiles that are representing 7 main tools, 7 main scenario. Each of these tools is mainly focusing on one persona. So Data Factory, well-known Azure Data Factory tool, but here again, some existing tools have been integrated finally together, but there are also some completely new novelties, meaning we have a new approach to the storage named OneLake. So it's very similar to OneDrive that we personally are having. Now we envision that our customers would love to store data in just one lake, one storage. That's why the fundamental pillar for the data is OneLake, and that is the novelty. The second novelty will be data activator to just quickly jump from telemetry to the actions. But then again, we integrated Power BI data engineering that you can do in Synapse, but with tons of the novelties, and always with thinking that we are targeting the end persona that is a data engineer who wants to do the job, not to over-engineer, and like over-engineer meaning inventing the wheel from the beginning. Okay, so now we'll focus on just one part, that is data engineering. And here we have a couple of like novelties for which Fabric propose. And how Fabric also simplifies the data engineering work. And starting with the first pillar of the Lakehouse. So on top of a Lakehouse, like on top of the one lake, you can create a Lakehouse. So Lakehouse will be a big storage that is kind of a storage house for all your data. Again, built on top of one lake. Lakehouse uses Spark, Apache Spark runtime. Like we ship the open source version, but again, we are adding on top of that our IP, our optimizations, and also our integration with the entire Azure platform. Then the Lakehouse can be used from two things, like Fabric, we can name it Studio, but like just a browser, through browser, we are accessing Fabric data engineering artifact to touch the Lakehouse and do the magic there. At the same time, we have a native integration with VS Code. Any questions? Because now it's the time for hands-on. No more slides.
Yep. If you have questions, just write in the chat or raise your hands. We'll unmute you.
Okay, so now I will share that browser.
So we have one question, Estera.
Yes. What's like in the meantime, I will start to share the browser, but I see that the question is what's going to happen with Synapse experience. So there is a video. So I really invite you to watch this Synapse channel on YouTube. There is a series about Synapse, but again, we started to record Fabric Espresso series, and starting from 10th of July, I will weekly provide the content about data engineering and data science and data integration in Fabric. And all the guests will be like product managers responsible for just the specific features. So I like hope for like really deep dive. And just back to the question, what is going to happen with Synapse experience? Based on what our VP Bogdan Kriviat said, we will continue to support Synapse. At the same time, again, Synapse will use some of the, and again, with Fabric, they are using similar components. At the same time, the IP optimizations are going to be added on the Fabric side. So we will develop at that point and focus on the Fabric. At the same time, Synapse is a GA product. We have a priority to serve our customers through Synapse, but innovations will land, like from my side, I can speak on myself on the Fabric side. And optimizations are in Spark. Yes, I can maybe tackle this, like answer this question at the end, because there are some cool features, like finally we don't have to deal with Spark properties and knowing 400 Spark properties. At that point, the most critical and the most impactful for our queries are optimized by the feature name Autotune. But again, let's wait for the end. I will maybe try to elaborate more, depends on the time. Now starting with sharing the Synapse, my browser. Can you see my browser?
Yep, can see.
Okay, so, okay, the link I've shared on chat, and let's start with that. Two things, downloading the notebook, downloading the data. I have it on my disk, so let's start with the very first step. Before that, just let me open my notes just to remember step by step and not lose any minute. Good. So we are starting with accessing the Fabric. I'm using the internal version, but again, you will have the similar features on your end. At the same time, you can switch the persona, the experience, when you click on the left button, bottom side. So I'm choosing data engineering. That is the place I wanted to author and show you the capabilities. And I will start from the very beginning. So as a new user, I'm going to create my workspace. So let's name it Norway, PE Norway, or just that. And here I can choose what is the license mode. I'm using the trial, nothing more, apply. Okay, I got a new workspace. Again, concept very similar from Azure Machine Learning, Synapse workspace, a place where I can create, author my my notebooks, jobs, and etc. So very clear notebook workspace. Now I want to import the notebook. So I'm going to Home tab. I'm clicking Import Notebook. Here, Upload, and I'm uploading the prepared notebook that you can access from the GitHub. Now it's going to, again, it's a very live demo. I have the backup version that yesterday everything was running, but wants to do fully live. So let's see if today everything will be fine. Okay, successful import. Let's go to the workspace. So what happened, I import the Jupyter IPython notebook to my workspace. Now I can just open it, and we can start having fun with the notebook experience. So in the middle, I have the authoring experience. I can write the code in PySpark, Scala, Spark SQL, and R. As you can see, I have not defined the runtime version. I have not defined the Spark version. It's not needed. Basically, right now we are I'm using the newest runtime, the latest GA runtime that is provided. The latest runtime, it's not GA because its Fabric is per se preview. So the latest runtime provided for this tool, and I can just start writing the code immediately. So we'll start with exploring the Lakehouse. First of all, you can see that on this panel, maybe this feature will work. So this blue panel is defining Lakehouse Explorer. So I can see what files I have in the Lakehouse that is attached to my notebook. At that point, there is no notebook. So the first exercise that we have to do is we have to create a new notebook. So just click Add, New Notebook, New Lakehouse, Add, providing the name, Bronze, because that is the notebook is right now using the code and assuming that we are using the Lakehouse with a name Bronze and the specific column name that we'll touch in a second. But firstly, let's create a Lakehouse. Super. As you can see on the left side, we created the Lakehouse that was immediately attached to the notebook. The name is Bronze. We have access to files and tables inside the Lakehouse, but again, it's empty. So now the first step, we have to ingest the data to the Lakehouse. And there are a couple of ways how we can ingest the data to the Lakehouse. We can use well-known pipelines from ADF. So here from Data Factory, we can use data flow. We can use copy activity, copy tool. We can use just Spark code to access, for example, Event Hub and to process the data and save it in the Lakehouse as part of the Spark structure streaming. So here, Fabric supports structure streaming, meaning there is no deadline when we kill the jobs as it is in Synapse. So basically, different ways. And today we'll explore two, like the most fancy from my perspective and the most exciting is we will leverage shortcuts. And the second, that will be at the end, we'll start with the basic ability to upload the data, that is using just direct upload. So we are going to now discover the Lakehouse built on top of one lake that is based on the Delta Lake open source library. It's built for us. Now let's jump into the Lakehouse, full Lakehouse experience, meaning that a couple of ways, but we'll start with going to our workspace. As you can see, there are 3 bronze artifacts. So we created a Lakehouse, bronze with the name bronze. At the same time, there have been 2 more artifacts, SQL endpoint and dataset. We'll touch it later on. But now let's jump into the Lakehouse. We got the full access. Previously, it was that Lakehouse Explorer. Now we have the full version of the Lakehouse and more capabilities, more features here. And what we want to do for the purpose of the demo is to just load the file. So here, there are 2 options. You can load the file to tables and to files. And best advice is if you want to load something to shortcut to add the data to tables, the data must be in a table format, Delta Lake tables. So if we have CSVs, Parquets, whatever the format is, whatever the file is, you want, the advice is to load it to the file section. So just click on the 3 dots, upload files. Now choosing the Parquet file from my local PC, clicking upload. And we have to just observe the loading process. So in the meantime, just to comment on that, Lakehouse built on Apache Spark will allow us for distributed big data processing. Again, I will repeat myself, built on top of one lake. Lakehouse will have 2 modes, Lakehouse mode, the default that we will use from the notebook, but also there will be a SQL mode that we'll touch at the end to basically connect Lakehouse experience with T-SQL lovers and users. Okay, we are close to that. Done. Fantastic. So we loaded directly from our PC the file. Let's close it. Now we can click refresh. And you can see that we loaded directly the Parquet file to the files section. Now it's a Parquet file, and we can handle it on multiple ways. Meaning from the code we can read Parquet, we can save it as a Delta. But the beauty of Lakehouse and the intention of having the Lakehouse is to use Delta Delta tables. That's why there is one feature that I really recommend you to use. If you code, you can do that from the code. If you don't, you can use it just as an option here. And the feature is load to tables, load to Delta, load to tables. So basically, this feature is transforming the files into the form of the Delta table. Let's click new table, and now let's provide the name. And please be cautious here. If you're following me, provide the name New York City SONYC_taxi. Let's click, and nothing more, just the name of the table. Let's click load. Now it takes a couple of seconds to load it. And I see the question, what compute engine does load to table use under the hood? Let me answer that. So when you create a workspace, you are using the workspace level defined runtime that is defined for you. And this version is used also by the load to table. For in a couple of months, we'll introduce the new runtime, and Lakehouse, and also the Lakehouse features, meaning load to tables, will be always using the latest GA runtime version. Delta Lake is backward compatible, sometimes not forward compatible. That's why this approach of using always the latest for the Lakehouse, based on like my research, will not bring issues, and we always will read the most, like the true results. Okay, so in the same time, as you can see, we got a table. No need to refresh. We can just load it to the preview. We can check the types, some visualization, what columns we are having there. And yep, all good. Now let's go back to our workspace and to the notebook. And now let's refresh the files, let's refresh the tables. Yes, we have the access. And now let's start with executing some commands. We are now, I will show you the content, what that is the contents for our lab. We discovered the Lakehouse. Now let's get data from the Lakehouse. And one nice cool way is that you can just use drag and drop, and then the code is automatically generated for you. At the same time, we have a code like prepare. So let's execute the first cell. That is, we are going to define the data frame. And here we are using Spark SQL. The cell type is PySpark. So Python, in Python, we are using Spark. And at the end, we are using the simple select statement that is choosing all from all rows, records from Bronze Lakehouse and from the table New York City Taxi. We are limiting 100 just to check it. Let's run it. And the biggest, one of the biggest difference comparing to Synapse, and also seeing the feedback for Synapse, is that in Synapse, as well as like in general in Spark, you have to wait for Spark session to come up, about 3, maybe 4 minutes. Here in we started execution in after 9 seconds in total. Now we are just querying, but in less than 9 seconds, we got the Spark session, and we were able to execute the query. So what happened? Basically, we have pre-provisioned pools, and when we open the notebook, we already knew that the session is there ready. We are starting the pairing mechanism, and when you run the query, we need just 9 seconds to pin your query with the session that is available. So no need to start Spark session. Okay, so yeah, we got the result. Just to show you that the results should be immediate comparing to the Synapse experience. Now let's, for those who are based on and fluent in writing in SQL, you can just change the type of the cell to SQL and use directly the query without any Spark magical code. And at the same time, here we should leverage the caching mechanism, so the query is returning immediately results. So the same, we selected the same query, 1000 rows from our Lakehouse. Now let's go quickly through the get data from the Lakehouse to explanatory data analysis, how to do that in Fabric, but here just showing you a couple of code snippets just to select a couple of rows and showing again under the hood caching mechanism immediate results, and show is similar but different method than display. With using display, you have the immediate access to the feature chart feature, and with show it's just to show the tables, show the results. And again, if you are dealing with massive tons of data, always better to use show at its limits, less memory usage for it. Now the exercise about data aggregation, summarization, and correlation, meaning as a data engineer, we want to do explanatory data analysis. So maybe should start with the introduction to what kind of data we are right now processing. So I am using New York City taxi data that is reflecting when, not who, but when, like which vendor, which cab was driving, and what was the price, so fair amount, was there any tax? So basically we will tackle the problem of analysis the open source data about like the car business, like taxi business in New York City. And the scenario here is that, okay, we have some initial data. Okay, we want to process it. So at the end, as a data engineer, we want to serve the insights for data analysts who are using Power BI and who are using, for example, T-SQL. That's why we'll connect the story at the end with Power BI and T-SQL. But right now, our goal is to process the data, meaning clean it and aggregate it. So I assume that like we landed the data, we created the Lakehouse with a name bronze. That's why it's showing us it's a bronze, meaning a raw layer. And ideally, we should create a second Lakehouse that will be having a name silver, and all the results, all the new table, we will add it there. But for the purpose of this demo, of this hands-on lab, I'm just using the same bronze Lakehouse, but keep in mind that the last extra materials here are about medallion architecture that you can pretty efficient have in Fabric. So now exercise about the aggregation, summarization, and finding the correlation. So a very efficient way of reading the delta table, just defining the New York City taxi name. Now let's clean let's aggregate the data. So we are creating a data frame, so reading the entire table and grouping the results by the year, meaning that there is a specific column. Maybe we should take a look at that. As you can see, it's a kind of a timestamp column. And now we have to process it in a way that we want to group it by the year, by the month, by the date. So just defining what is the column, creating the alias using the method year from the PySpark SQL functions. At the end, we want to order that by year and the month, display the result, and here, important point, we want to create a new delta table, format delta with mode override, and the method that we are using is save as table, as again, this will be the method rather than save that is optimized in Fabric more than the save. That is our guideline to use save as table, not to use save. And that is the result. So our table has been created. To see that at that point, we have to refresh. So click 3 dots on the Lakehouse Explorer and click refresh. As you can see, we got a new table with the results. Let's jump into some task of explanatory data analysis. Here, we will load the tables, and this is a different way of loading. As you can compare, here we just read table. Here we can load and define table New York City taxi. So 2 alternative ways. And we know that data is not always on the proper schema, not always we have all the results. Sometimes we have nulls. That's why we want to clean the results, and we want to remove invalid records, meaning that if we got the service of be driven by the taxi, then there should be some mechanism, like the fair amount should be more than 0, or that's the general example. So that is a very simple rules. The goal is we want to use the filter method, and let's run the cell. At the end, we are renaming the columns. and writing the format, the final table, that is New York City taxi cleansed. And we can see how many records we removed. At the end, again, we have to refresh it. But this is just showing rather Spark, PySpark capabilities than Fabric as the same experience, and that as this one, the same code will work in Synapse. But here, what is unique, you have the combination of access to the Lakehouse on the same screen as Notebook, and also the optimize command for saving and reading the delta. Now let's jump to the simple examples of like some counting, checking the types of the data frame, grouping, and selecting min-max value. So when was the first write in our data set and the oldest, you can do that and follow on your own. I want to go to the moment when, as a data engineer, many times we have to prepare some charts. Some of you will use Power BI. Some of those more close to data science will use Matplotlib library. And again, it's built into the runtime. You can just, once you loaded the data frame, you can visualize it. It's part of the runtime. It's available for you. Just import it and draw the chart. Then you can save it, load it, and further process. And the second example with scatter plot chart, when we want to check the correlation between fair amount and the trip distance, meaning as a data engineer, we got a task to find the correlation, like prepare the data, maybe find the outliers, like here, meaning that we paid, the trip distance was huge and the fair amount was very small. No, something's happened here, the same as when there was a very short trip and we paid a lot. The easiest way to clean the data, to make a proper decision how to remove the outliers for further processing is, let's take a look by the chart. And now going to the more advanced scenario, meaning we have some libraries that are part of the runtime. And here, sometimes we have more sophisticated needs, and we want to install our own libraries. So the point is that every runtime comes with some pre-installed libraries. You can check it by going to, for example, like for Synapse, if it's 3.3 runtime, you can check tons of libraries that are shipped within the runtime that you can just access, use it immediately. At the same time, there is an option to install your own libraries. And I know that in Synapse, we have waited some time to have this feature, library management. In Fabric, it's natural without any magic command that we are going to use just pip install and what is the name of the library for those who are using Python. So here, the scenario is that, okay, as a data engineer processing this New York City taxi data, we create this chart. But again, I can just, download it, and it's not an interactive experience. And I heard that, for example, the Altair library is providing me with some extra experience, meaning I can do some interactive analysis there. So what I want to do, I want to add this library to the runtime, to the session right now I'm using. And here pips let us to install, to manage, to update all the Python libraries from the different sources. It happened in less like 7 seconds. Fantastic. So it means that we have this library in our runtime. No need to restart to do anything. Just let's just use it. So the code prepared for this example is, again, some visualization, but this is to demo that one command, no magic, no some percentiles, nothing more, just pip install the name of the library, and we have it. And at the end, it should be a little bigger. At the end, we are getting an interactive way how we can dig into, how we can visualize, and how we can do some analysis of this data with using our own library. Here I use the open source Altair library, but in case you wanna to build your own, you can bring it through library management feature as well. Okay, now we have just three in total more exercises. Now the shortcuts. So let's pause for a second. And we'll start with the context. We have some data loaded to the Lakehouse, different ways of loading, but sometimes or many times we want to kind of side load the data, either from different external sources like Amazon S3 or tons of ADLS Gen 2, so data lake storages built on storage account in Azure. Some are operated and populated by Databricks, some are used in Synapse, different places, but at the end, storage account is kind of a pillar of Azure as a service. And now in Fabric, because we want to have this one lake approach, we want to combine all the data assets that we are having in our company. And also the point is that we don't want to copy the data. We don't want to, as previously, create the definition to the access to the storage account and then copy the data and wondering use copy data tool and then use and check what is the throughput, how long it takes to load the 1 terabyte of data. It's not needed anymore because we have the shortcut feature. So now in our scenario, we are doing the analysis of the New York City taxi data, and it turned out that our task is to enhance the data set with pulling some information about the discounts, meaning that we got the table. I will go back to the beginning. So we could see that there is a vendor, there is some distance, there is some. Maybe I will make it a little bigger. Some passengers, how many people were driving there, distance, and so on and so on. But the most important part, let's assume that we are Uber, is what is the fare amount, and also what is the tip amount. And sometimes you can find that specific companies are offering specific discounts, and those discounts are invisible for the drivers, are visible for the users. In this case, we want to calculate what is the, based on the specific date, there is a discount. And at the end, we want to calculate based on the fare amount, the value of the discount. Meaning that right now, if we are going to summarize all the money we earn without counting the discount, we'll get the wrong number. So the goal is to pull some data, to shortcut some external data, and merge those two data sets, pivot them together. But firstly, we will start with creating the shortcut to a Lakehouse. Here, providing all the details, but now I'm going to show you how to do that. There is no way to create a shortcut using Lakehouse Explorer because we want to create a shortcut to our Lakehouse, but this is just Explorer, the minimum version. To have a full experience, again, we have to go back to our workspace and just enter the Lakehouse named Bronze. Okay, now we have both tables and we have files. Again, because the data set is prepared for you, the type of the data is CSV. So CSV is not the Delta table. That's why we will create a shortcut to the files. But if there is if the data is as a Delta Lake, meaning, for example, most of the scenarios from Databricks are about exposing, saving the data in a format of Delta Lake, then you can create a shortcut to the tables. Now let's create a shortcut to the file section. So clicking 3 dots, new shortcut. Now at that point we have like 3 options internally. So some OneLakes, internal OneLakes. External sources are ADLS Gen 2 and Amazon S3. In our case, we want to use ADLS Gen 2. Now let's create the connection to this storage. So I will copy the URL, all the information you have in the notebook. So I have the connection previously created, but let's create from the beginning. So connection, create new connection. Connection name, whatever the name is, or okay, I provided the most clearer name, new connection to ADLS, maybe 2. Then we have like 3, in total 4 ways of how we can access the storage, this storage account AGLS. We can use account key. In our case, let's use SAS. I also provided you with the SAS token. This is my personal external Azure account, so like there are no important information rather than this simple CSV, so you can easily access it. Let's click next. Invalid credentials. I thought it would happen. Let me find it. Maybe I just copied wrong credentials. Does it work for you? Maybe this token has expired. 28. I guess yes, invalid. So let me quickly regenerate the SAS token. I guess that the date is invalid. So I need 1, maybe 2 minutes to do that. Okay. 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 I need to check my account to get the key, security key to access Azure portal. And now let me create a new SAS token that will work for the next week. And I will just copy here and check if that works. Good, it works. So just I wonder if Teams will allow. Yes, share it on the chat. Yeah, the message was blocked because yeah, that is what Teams is doing. Let me do it very engineering way, create new file. The name would be token. You have it. It should work. Okay, so let's continue. Here, providing a shortcut name. So what we did, just super, it was fantastic. So we configured the URL and the SAS token. We could use an account key, but again, SAS token will be better. And then we have to provide the name, side loading data discounts. Let's use it. Now, just a subpath, meaning folder or container path. In our case, it's just data. Okay, now let's create it. Done. Immediately we could see that we got a new kind of a folder that we can enter. And inside this folder, we can see that there is a generated New York City taxi green the discounts. This data set is like fully generated, if fakely generated by me, so no issue with using it. And now we check that, like, we created the shortcut, we checked there is a file. Now let's refresh. 3 dots, let's refresh our file section, and we have the access to side loading data discount. So this is the name that we defined as a name of the shortcut. We can just enter it and see, yes, we have the CSV file. Okay, now the exercise with like for me is about, like, that was my intention when I was creating it. So creating a shortcut to external data storage, showing you no need to copy data, no need to use copy data tool, just creating a reference to the external storage. And from the data engineering perspective, we want to do just one thing. We want to merge two data sets, meaning we want to merge New York City taxi data delta table with some CSV results, and we want to do some pivoting stuff. Why? Showing you, starting with loading the new data, so the CSV with the discounts. As you can see, we have just two vendors, so two corporations that are running this taxi business, and per every day, those two corporations exposed, shared what is the discount value for the date. And now we want to merge it with our initial table, but as you can see, it's slightly different, meaning that we have some vendors, and meaning that we want to transpose the pivoting or unpivoting, depends from which side, but we want to transform this column and like this entire data set. So first of all, we will unpivot, like the proper transformation would be unpivoting side-loaded data. Here, just one small thing is that right now we are using Spark runtime Spark 3.3. In Spark 3.3, there is no pivot and pivot command. So that's why I was finding this code as a workaround, meaning using pandas and some transformations, but it's not the point. The point is that with Spark 3.4 that we committed will ship into Fabric within a couple of months, there is a pivot. That's why I will refactor this code, and at the end it will just one line of the code. Right now, to do this pivoting and pivoting, we have to write this code. So first of all, loading the data frame, transforming it to pandas, melting, creating a new data frame named discount Spark data frame, and now the proper structure. So vendor, what is the date, what is the discount? We want to join it with the final table. That's why we have to prepare this data for the join. So again, this is the data set A. So side loaded data. The data set B is the original data, New York City taxi. Let's load it again to a new data frame. Good. Prepare two data sets. Now let's join them too. So just referencing those two data frames, creating some aliases. At the end, we are using the method join to join them to, and the type is inner. Let's run it. At the end, we are saving the results as a New York City taxi with discounts. Done. So I'm just interested in the, those two, like 3 in total columns. So let's refresh it. And we have it. And that's all for data engineering stuff here. So our job as a big data engineer is right now done. And now let's assume that we are working with some T-SQL or lovers, users who want to use the same data set. We will go to the workspace, enter the Lakehouse. And here, I want you to be cautious and pay attention to the specific mode. So at that point, you can use Lakehouse in two ways. One is Lakehouse, meaning Lakehouse mode. They allows you, as we did, deal with tables, files, folders. The second mode would be SQL endpoint mode. This will let you use SQL, T-SQL, to read the data, to manage tables in creating the Lakehouse. So the exercise I want to show you right now is how you can use T-SQL, just very simple queries, to query our initial Lakehouse. So I switched the mode from Lakehouse to T-SQL. I entered this experience. Now I will write the new SQL query. Standard, typical one big cell for writing my code here, and very simple. Again, it's not Spark SQL, just clear SQL. Select star from New York City taxi. Let's run it again. Under the hood, we have a compute that will serve to execute this query. And yes, in 11 seconds, we are getting the first results. Okay, why to use it? If there are people who want to use T-SQL, it's the place for them. At the same time, there is, I believe that one critical scenario, we still want to use those two modes together, meaning that I believe that Lakehouse mode, Spark for big data processing, distributed processing, cleaning, medallion architecture, perfect. At the same time, at that point, there is no feature of Spark views. So what we can do right now using this experience is to do everything in Spark. And one feature that I really like in this SQL mode, SQL provided by SQL endpoint, is that we can create the views. So let me find the node, what kind of view I want to create. Yeah, we'll create a view just a very simple view, meaning create view, New York City taxi, as select star from New York City taxi, whatever the column is, cleanest. Let's run it, execute it. Okay, let's check it. So here, refresh. Yes, we have a view that we already created. And here the scenario is that some Power BI user will access it directly. At the same time, the last point I promised is native integration with Power BI. So here, let's choose the reporting, new report. And here, the Power BI comes with a very needed feature named Direct Lake. So let's alter the diagram, and then I will comment it on top of the result. So very quickly, we have the access to our Lakehouse immediately. So all the artifacts are here. All the views are here. So let's use the maybe cleanse data. I want to create a pie chart. Okay, and the column are fair amount. So I want to see what is the, just by looking on the pie chart, what is the, in terms of the all amount that people spend on driving by the taxi, how much they tip. So one of the things that once I moved to US that surprised me is that everywhere I have to provide a tip, and the tip is usually 20–25%. And this, by looking at this chart, you can quickly realize if people are following the same rule when driving by the taxi. It looks at no. But again, just showing you how to access immediately, how to create the how to alter the dashboard immediately. Another chart would be the type name stacked area chart. And here I would love to use the pick update. Find it. Pick update. Yes, that's it. And again, fair amount. And we can see that that is some interesting situation that some data analyst would love to dig into that. So the question about direct mode versus the direct query mode, direct link or direct lake versus the direct query mode that is well known and working for the Power BI. So here, like traditionally, direct query mode relies and retrieves the data from the source each time when it's queried. So the query performance depends on how quickly the data can be pulled from the source to the engine that is doing this operation. And this method doesn't require copying data, but because it's just pulling the changes instantly, and the changes are reflected instantly in the query. But we have also the import mode, which means that we pull the data, put in our memory, and without querying to the source each time, we have the data ready for our dashboards because it's in memory. So here, Power BI needs to copy data into the data set when every time when it's refreshed. And the changes at the source are only updated during the next data refresh. And the beauty of the direct lake mode is that it removes this mechanism, meaning there is no need to import process by loading this specific data straight into the memory, meaning that comparing direct lake mode will be the best choice because we will have the data like immediately waiting in our memory that you will access it from those two places, meaning that clear Power BI and going through data engineering or data warehouse experience and authoring at the end landing on the same site. But no need to load it. And let's start. I would look at the questions, but the last point that I prepare for you is let's leave it, medallion architecture, and you can see that in the notebook. Just to comment on that, medallion architecture. Again, there is a feature undergoing feature named multi-part naming, how we want to access different lakehouses by different people, different users. But the current proposal suggestion is, again, we can have and attach multiple lakehouses to our notebook. At the same time, if you are using PySpark, you can always, and again, in SQL, it's like, my recommendation is to use PySpark to access the tables from different lakehouse from one notebook. So at the end, your notebook can read the data from bronze and save to a different lakehouse named silver, and etc., etc. And that is the code snippet here that you can follow. And that's all. Let's start with question, thoughts.
Yeah, there's a lot of questions in the chat. I can read some of them for you.
Super.
Structure streaming at times is slower than stream processing for large volumes and needs significant resources. Are we going to have option to use Apache Flink or other alternatives here?
At that point, again, tested Spark structure streaming. I did not have heard about Apache Flink and alternatives here. It's rather for streaming scenario, Spark structure streaming, and again, looking at, I would say that maybe Data Factory or real-time analytics will came up with something. I believe that at some point we'll came up with the native integration with Event Hub. At that point, the easiest option is just to use, I tested a couple of days ago, create the Event Hub, connect it from Spark. It's working. The job is running for a couple of days. But at that point, nothing more above that. Again, if you have any suggestion, there is a page that you can suggest, like with your ideas. Let me find it. Yes, Fabric. Because you have the access, the power to prioritize the features. So again, if there is something you want to see, please add the idea and make sure your colleagues vote for it, because the top are getting the proper fast priority to get implemented, like dark mode. That is like the most people are voting on it.
Yeah, another question here. Is there going to be any feature mapping, for example, merge statement compatibility, table design guidelines, etc.?
Trying to find it. Is there going to be a feature mapping? I mean that for Delta. So right now we have just one Delta. Between Delta Lake in Lakehouse and also like the SQL is implementing it. Yes, that should be. We'll add more in the upcoming months. We will introduce new Delta version 2.4, and then yes, again, before half hour before our this meeting, we had a conversation about it. So design guidelines, yes, it should be published, but again, I would expect that rather late fall, there should be new articles on our documentation about it. This is more on SQL compatibility side. Okay, I can follow up on that. It is a different PM that is leading this effort. Like to be 100% sure, I can follow up and we'll share the answer with you here on the chart or with Pete.
Maybe I could ask you a question, Estera. When do you expect this to go GA? Is there any timeline? Is it this year? Or is it...
That is a very difficult question.
Yeah.
Transparently, soon.
Yeah. Yeah.
But I can't share the date. But
no, I know
soon.
that you can't share the date, but yeah, so I know. So
we are
soon,
really doing hard to. There are, of course, some like features that will fully make it like enterprise ready, and tons of time we are spending like in what shape we can share it as GA because we want to, and a lot of components are GA outside Fabric, so in Fabric should be soon GA. And again, my answer would be soon.
Yeah, thanks.
I see the question about concept of RLS and CLS brought here. It's undergoing discussions again. And how it's going to be applied on shortcuts. I would love to connect you, Sanket, with again, we are looking for like collaborating more with community, looking for some validation of the design feature that we designed. So if you want to ping me, like share the message with me, I will connect you and you can impact the design for it. Is there any API to create shortcut? API will came with Fabric GA. Can I ingest data from files, Parquet or CSV, and create table using SQL? Like very good question. Based on my base knowledge, in data warehouse mode, yes. In Lakehouse SQL endpoint is just for reading, like not for writing. So creating views, yes, tables not. Are the order Bloom index filters supported? Let me check it. So I will check it and also let you know. What is the RLS and CLS? Do we have a timeline? Softly, I believe it's Fabric GA. But like I will not give my head to cut if it's not far. It will land early post GA. Is there any pitch deck available that we can use for clients?
I think there is one on their website. I can share the link.
Oh, super. Other than that, yeah, I'm not aware. Spark optimizations, yes, my favorite one. So again, those which are shipped, available, and I'm looking for with a team. I'm looking for people who like customers who would love to help with validation. So we have a feature auto tune. Let me share the screen again. This feature is optimizing, like we look at all the Spark properties and find 3 that are critical for querying scenarios. Partitions, configuring the table that is going to be broadcast because the default is 10 megabytes. Mostly we have it like slightly, not slightly, like significantly bigger, and max partition bytes. So 3 Spark properties that we are optimizing. Under the hood, there is an ML model. So basically, if you are running your query a couple of times, so you have a repetitive job, then we are discovering the pattern, the data cardinality, and optimizing those 3 elements. Based on, again, TPCDS results, for some queries, the boost is 70% in terms of performance. For some, it's about 15%. And right now we have confirmed that on the TPCDS with some early customers as well. And if you would like to be one of the customers like that, you would love to work with the product group specific team on validation of AutoTune, please reach out to me again, to enable it in all production subscriptions. I'm looking for this anecdotal confirmation and also confirmation from the telemetry side, because without it, right now, AutoTune is available. You can run it. I mean, you can enable it and you can use it, see the acceleration and see what are the parameters suggested by AutoTune, but it's not enabled by default. So to have a win-win, if you are willing to test it, please reach out to me. In terms of other Spark optimizations. So please dig into Delta, as they spent also the optimized, right? So they spent also the time on optimizing and choosing the proper parameters, but meaning that they set it by proper defaults, optimized defaults for everyone who is using Lakehouse, Delta Lake on one lake. So the difference is that in AutoTune, it's up to every query and up to every user. For the Delta optimization, it's just optimized global properties. I believe, like, I have it on my roadmap that AutoTune one day will optimize also Delta properties, like Spark Delta properties, but at that point, it's just on the roadmap. Link to the AutoTune, yes, it's sharing. In terms of other optimizations, so frankly speaking, we have a high concurrency mode that will be rolled out soon, and it was already announced, meaning that high concurrency cluster from Databricks is similar here, meaning that multiple users can use the same capacities, the same compute. But in terms of the biggest optimizations about the Spark, those are coming early, like early this year, and I can share as well as I'm looking for the customers who would love to be early adopters, so gated private preview of these features. I have 2, both are connected with Spark optimization. We are approaching the native approach, meaning that removing some JVM magic and replacing that with native, meaning C++ code, C++ optimization. At that point, I can say that, again, based on TPCDS, the performance is significant with like there are 2 separate features. I can dig into the details, but here I need we need NDA to discuss it and then join the gated private preview for you, for the customers. What I'm just looking for is like specific write scenarios, because I'm focusing on writing in one project. And the second, I'm focusing on like all the cross usage of the Spark. So on not only writing, but reading and doing all the operators, data types, and methods. Good, we are on time almost.
Yep.
I
And
see the, yeah, please go ahead.
Yep.
Just disappear.
Thank you. That was very insightful session. I'm quite sure that everyone has learned a lot. And thank you all of you for joining us, being part of our first session. We appreciate your presence. And we definitely will bring more informative and exciting sessions. You can connect with us on LinkedIn, Meetup, and Microsoft Community. I'll post a link for you. And once again, very big thank you for Estera for come and share his valuable time and valuable contribution. Thank you. We're looking forward for you in the next event as well.
Thank you so much for organizing, and fingers crossed for your groups. Happy to be here in sometimes once more features will come. And also, again, remember, like if you have a customer, if you want to try some gated features, I need to, I want to get the confirmation, not only TPCDS, TPCH, DI, whatever the benchmark is, but on customer data, because we know that all the benchmark are as a car, 5 seconds to 100 kilometers per hour, but the reality is sometimes different. So happy to collaborate. Thank you so much. Have a good evening. Bye-bye.
Bye.